everything about them, but let's review everything. So quadratic functions. And they can appear to us in two different ways. Either f of x, which is ax squared plus bx plus c, or another form, which is basically the same thing, and you'll tell me what the difference is. X minus h squared plus k. I claim that they are the same. And you can say, but they don't look the same. They don't. I completely agree. They do not look the same. But they are the same. So can anyone say anything about the first form in comparison to the second form, or anything about the second form in comparison to the first? What is the difference, if you want, between the two? Can anyone tell us the difference between these two forms?
The second form, I think we have to determine the x minus h squared.
So in the second one, you say that we are determining something?
Yeah. It's the same thing.
Yeah, it is the same thing, but what is the difference? Correct, I agree.
They're like, the way we play order operations, like we're.
You have something, yeah, I agree. I agree. But it's much simpler than that. The second one has something that the first one does not. A perfect?
Square?
Exactly. Do you see the perfect square? This we cannot graph using transformations. This one we graphed many times using transformations. So then which one of these two do you think is easier to graph when we have examples? Of course. Of course. Here's an example of the second one. Let's say f of x equals negative 2, x plus 1 squared minus 3. We can graph this function in our dreams without even doing anything. Here's x squared. Where do I shift it first? I mean, left how many? What do I have to do next? And then? And then? What is the vertex? Comma? Correct. What is the range? 2. Done. And I didn't do anything. I just made a fool of myself in front of you. And we know the graph, right? One more time. This is x squared. We didn't do anything because this is from transformations from 2.5, correct? X squared, x plus 1 squared, 2 times x plus 1, negative 1 times x plus 1, negative 3. The vertex, negative 1, negative 3. Okay, so in this particular section, we are really trying to get a perfect graph. Can we graph it right away? Yes, we already did that. So let me just quickly sketch the graph. So this is x squared. Here's x plus 1 squared at negative 1. Then we stretched it by a factor of 2. Okay, here it is. I'm exaggerating, but you know what I mean. Then we flip it. Here it is. Exactly all those symbols that I showed you with my hand, my arms. So this is negative 2 x plus 1 squared. And then you said, okay, now you have to shift it down 3. So it's done. Right here. So here's the graph. I know for sure that the vertex is negative 1, negative 3. There is no secret there. However, in this particular section, we want to go step by step and present the entire graph. Here, I can't tell you what the Y-intercept is. I didn't even determine it. Is there an X-intercept? Absolutely not. And also we know that already that the range is negative infinity to negative 3 without doing much. Okay, so now let's start from scratch here and go through step number 1, which is the shape. How do I know the shape? First of all, the graph of a quadratic function is a parabola. Exactly what we graphed here. This is a parabola, this is a parabola, this is a parabola, this is a parabola, this is a parabola. And any quadratic function has only 2 possibilities. Either it has a minimum or not both. What is the second option? It has a maximum. Here's the minimum right here, and here's the maximum. These graphs, or I should say the parabola, is a symmetric function, a metric graph. So it has an axis of symmetry. We're not talking about a function being odd or even. I'm only saying that every parabola has a vertical line that can be folded by. So if I do this, then these two will overlap. If I fold with respect to this line, these two will overlap. So we're not talking about odd or even. We're just saying that the parabola is a symmetric curve. Is a symmetric graph with respect to the axis of symmetry. And we'll get to that in a minute with examples. Okay, so now how do I know whether it has a minimum? And by the way, that's why I wrote V. So this point is called vertex. Of course, this one is also called vertex. It doesn't matter, min or max. That point is called the vertex. Okay, so how do I know without graphing the function like I just did in a blink using transformations? How do I know what is the shape? If the leading coefficient is positive, the parabola has a minimum. If the leading coefficient is negative, the parabola has a maximum. Which I knew from the beginning that by comparison, look at this. This is A and this is -2. So this is the leading coefficient. So since the leading coefficient was -2, we all knew that the parabola had a maximum. And when we graphed it quickly with using transformations, we noticed that as well. So this is our case for this particular problem. In number 2, we want to find the vertex. The vertex is easy to find. There is no calculation required. So here, for this particular function, the vertex is h comma k. So looking at our function, what would you say the vertex would be? So the x coordinate of the vertex is h. Since there is a minus here, but there is no minus here, so obviously this number must be -1. And this number just gets copied. A few minutes ago, we determined the vertex. -1 comma -3. That's why I did it quickly using transformations, because I want you to see that it's really not a big deal. It looks difficult, but it's really not.
So the vertex is h and
It's the same with this circle, if you remember. X minus h squared plus y minus k, the same setup. Yes, exactly the same idea. Okay, so we have the vertex number 3, X-intercepts if they exist. X-intercepts if they exist. Okay, what does that mean? So let's analyze a little bit here the possibilities, and then we'll draw a conclusion. Well, I don't know what to do here. Sorry. Yep, that's the time of the year. I can't do anything. let's continue. I'm sorry about that. Okay, I'm just going to try to stand in the way, maybe. That's better. Okay, so if they exist, what are the possibilities for a maximum? So we are discussing all possibilities for a maximum. So here's a possibility for a maximum. Here's another possibility for a maximum. And here's another. We're talking about the x-intercepts. Does this graph cross the x-axis? Twice. Very good. Does this graph cross the x-axis? Yes, in only one point. We should say it's tangent. I wouldn't say it crosses because it doesn't go to the other side, but it's sufficient. Does this graph cross the x-axis or touch the x-axis? No. So how many x-intercepts, if this is our case, how many x-intercepts will we find? Excellent. 2 distinct x-intercepts. If this is our case, how many x-intercepts we will find? Yes, we will say 2 the same or just 1 solution. That's fine. 1 x-intercept. Correct. Okay, what about if this is our case? Because we can't have more than... Yes, Yala, go ahead.
So if it was like a test or something, we would have to write like 2 distinct, we would have to write that?
If the problem is asking, yes, I will get to those problems.
Okay.
Absolutely. Yes, yes, of course.
Or if we could just write 2 x-intercepts and be done with it or whatever.
Well, excellent question. Excellent question.
But if you're getting to it, it's fine.
Both are 2 solutions.
Okay.
Okay, look here. Look here. 2 solutions, 2 solutions. But here they are not distinct.
Right.
They are the same.
Right.
And here they are distinct. So to differentiate between these 2, you have to say 2 distinct.
Okay.
Here there are still 2 because it's x squared. I still have 2 solutions. Every quadratic equation has 2 solutions. Real, imaginary, I don't care. The same, I don't care. It has 2 solutions, right? But this one has the same. You can write, if you, bless you, you can write 2 identical x-intercepts. There is no need for that. But that's what happens here. Okay, perfect. Now, how many solutions here? No real solutions. They are imaginary solutions, but they're not relevant here. Okay, how do I know which situation? You can say you already graphed it 5 minutes ago. Why are you asking? Oh, well, here's my question, and here's my answer to you, to the question. Well, let's look at the vertex. The vertex is at -1, position at -1, and what is the altitude of the vertex? -3. Can this be the case? No, because here the vertex has a positive altitude. Whatever it is, but it's positive. Would you agree? What is the altitude of the vertex here? Exactly. So in this particular case, the vertex and the x-intercept, or intercepts if you want to say, is the same point. So the vertex and the x-intercept, they're all the same point. Both the same point. What about here? So this is definitely not the case, because you already told me that y has to be 0, but y is not 0. Okay, let's analyze the last one. What is the altitude? If the altitude is -3 and the parabola has a maximum, can this parabola touch or cross the x-axis? If its maximum value is -3, can it touch the x-axis? No. So in our case, you don't have to cross it out, but you know what I mean. This is not our case. This is not our case. Yes, this is our case. Should I waste my time on finding or trying to find the x-intercepts? No, of course not, because the parabola doesn't even touch the x-axis. So I'm going to say none. I'm not going to waste my time. I already know the vertex is somewhere at -1 and the altitude is -3. It cannot touch the x-axis because it has a maximum. Okay, number 4 now. Y-intercept. Can I find the y-intercept? I can always find the y-intercept for polynomial functions. How do I find the y-intercept? For any function, how do we find the y-intercept? Yes?
0.
Which variable? I'm talking about the y-intercept, not the x-intercept. It doesn't exist.
Okay.
So what am I trying to find?
Max.
Careful. How do we find for any function the y-intercept?
Oh, max is 0.
Of course. When x is 0, I have to find f of 0. So now let's go back to our function. Let's do this together. How much is 0 plus 1? 1 squared. 1 times negative 2. Negative 2 minus 3. That's it. So, exactly. So then, what are the coordinates of the x-intercept? 0, negative 5. Perfect. Any questions? So over the weekend we forgot everything? Is that what you meant?
No, I was just saying I felt like I just did this because I was like doing homework. Or
Of
whatever.
course.
And then she just was like, she said it was a review, and I was like, oh yeah, she did too.
Good. You're way ahead of me. I love it.
It's Monday.
I absolutely love it. Okay, number 5, axis of symmetry. It's not part of the graph, but it has to be graphed. So we know that the vertex is negative 1 comma negative 3. So I'm just going to plot the vertex. I hope you agree with negative 1, negative 3. Is this the vertex? Yes, we agree? Negative 1, negative 3? Okay, perfect. Now, the axis of symmetry will be the line, the vertical line, of course, that goes through the vertex. Can anyone give us the equation of this line? That's it. Is the vertical line passing the vertex? Of course, it will always be x equals negative 1 in this case. I mean, the x coordinate of the vertex. So x equals negative 1, axis of symmetry. 6. Does this function has a max? Does this function have a max or a min? Very good. Max value is, can anyone tell us what was the max value? Of course. And finally, you already told me, we already wrote it, let's write it again, the range. Negative infinity till? That's it, awesome. See how this, in view of studying the transformations in 2.4, 2.4, or 2.5, see how easy this was? Effortless, I would say. Okay, you can say, but you didn't finish. Yes, I know I didn't finish. So now we're ready to graph the function. We always start by graphing the vertex. Here it is. We continue by graphing a dashed line, not a solid line, which is the axis of symmetry, x equals negative 1. I only have one more point, which is 0, negative 5. So this is negative 3, 4, 5 right here. And now I'm ready to graph the parabola, trying to make it as symmetric as possible. So on the other side, I'm going to draw or plot another point, symmetric, 1 unit away, 1 unit, 1 unit, 1 unit away from the axis of symmetry, so that I can graph the function. So this is the graph of negative 2 x plus 1 squared minus 3, and this is exact. Any questions? Any questions? Try not to make it too acute. Do not make it like a absolute value at the vertex. Make it as round as possible and as symmetric as possible. Is my graph perfect? Far. Far from being perfect. As you see, this side is a little bit slimmer than this side, so that's the best I could do with what I have. But at least I did not show something like this, right? That's what I meant. Say it again.
So to do the other 2 points, you said you just went one away.
This was the vertex,
Yeah.
and this was determined 0, -5. A few minutes ago, we determined the y-intercept.
Oh, okay.
And then since this distance is 1 unit and the graph is symmetric, I went to the other side of the axis of symmetry 1 unit. Well, obviously, it's very clear I went a little bit further,
Right.
but at least I didn't show something like this.
Okay.
That would be incorrect. This, I know it's not perfect, but that's all the best I could do with without the graphing paper and with these markers. Any questions? So this was the easier one. And now let's look at another type. Still the same thing. But in this particular case, this is not, the square is not completed. Will I waste my time to complete the square? Absolutely not. I still have to go through the same 7 steps. In step number 1, I will identify the shape way before I graph it. And the shape is max or min? Yes, because the leading coefficient is positive. The leading coefficient is positive. Therefore, the parabola has a minimum. And number 2, I need to find the vertex. Well, the vertex requires effort now. In this particular situation, there is some effort. And here it is. I'm trying to find the x-coordinate of the vertex first. And I want to, anyone remembers the x-coordinate of the vertex other than Vinny? Anyone? It's okay, that's fine, no problem. So if I have this quadratic equation, it's already set up correctly for the quadratic formula. Can anyone now dictate the quadratic formula? Not this. This. We need to know the quadratic formula, and I'm sure we know it. Excellent. Yes. Excellent. Great job. So you can say, what's the connection here? What are you trying to do? I'm trying to connect this that we all need to know to this. Very easy. Very easy. Oops, I didn't mean to erase the denominator. It's this. So if we remember the quadratic formula, we should remember the x-coordinate of the vertex. It's everything except the plus or minus. Okay? Everything except the plus or minus the square and the square root. That's the x-coordinate of the vertex. So I want you to remember these together. If you remember these together, then you'll have no difficulties for the vertex. Now the question is, how do I determine the y-coordinate of the vertex? Let's determine the x first. So negative b over 2a is negative. Can anyone identify b? Very good. Can anyone give us 2 times a? 2. So the answer is? Careful, one more time. Very good. So the vertex has 2 as its x-coordinate. How do I determine the y-coordinate now? What do I have to do? Thank you very much. Indeed, this is f of negative b over 2a. So this indeed will be f of 2. We know that from studying functions in chapter 2 and from before. Excellent. Thank you. So f of 2, I plug it in. 2 squared minus 4 times 2 plus 4. 2 squared minus 4 times 2 and plus 4. How much is 2 squared? That's where I have to start because of the order of operations. How much is 2 squared? How much is negative 4 times 2? plus 4. So the answer is agreed? Correct? Good. So then the coordinates of the vertex for this particular function are 2, 0. Number 3, X-intercepts, if they exist. So, comma, right, exactly. So let's analyze what can happen with a minimum. This is an option for a minimum. Here's the other option for a minimum. And here is another possibility for a minimum. How many X-intercepts here?
I mean, 9.
How many here? You can say 2 the same, or you can say 1. Perfect. How many here? And we have to use one more word. 2 distinct. 2 distinct, 1 which must be the vertex. If that's the case, it's not only the X-intercept, but the vertex. And that's the situation. 2, 0. So this will never be 2, 0. This will never be 2, 0. It's not possible, right? As the vertex and X-intercept, that's all I meant. So this is the case. So our situation is not this and is not this. Of course, you don't have to analyze these all the time. I just needed the first 2 examples to see what make sure we understand what we are doing. Okay, now number 4. And then we'll look at word problems. Number 4, axis of symmetry.
So we don't have to do the Y-intercept.
I'm sorry. Y-intercept. Thank you very much. I can't get away with anything in this class. And I don't want to. And thank you. My apologies, of course. In my mind, I was already in the axis of symmetry. We'll come back to it. So this will be 5. Sorry. Okay, how do I determine the Y-intercept for any function all the time, forever? F of 0. Now this is much easier than with the other form. 4, 0, 0, 4. Very good. So can anyone give us, can anyone give us the Y-intercept? That's it. Let's go back to the axis of symmetry and let me refresh your memory. The vertex is 2, 0. The axis of symmetry is the vertical line passing through the vertex. X equals 2. Very good. This is the axis of symmetry. And number 6, so 4, 5, 6. Max or min for this function? Okay. Mean value of f of x of the function is? Careful. That was the Y-intercept. Both the axis of symmetry and the min or max value come from the vertex. So then the minimum value is 0. Number 7, we haven't even graphed it, but we have a picture in our mind. So, our minds, the range is
0.
That's it. Good. So let's graph this one. We start with the vertex. We always start with the vertex, 2, 0. We continue with the axis of symmetry always, which is x equals 2. We don't have other x-intercepts. That's all we have. And we do have a y-intercept, 1, 2, 3, 4. At this point, I'm trying to make a symmetric graph to the best of my abilities. So I can draw another point on the other side. I can plot another point, roughly, to make the graph symmetric, or in the best shape I can. Please, if you remember, I kindly ask you all the time to write somewhere close to the graph, below, above, in between the 2 branches, anywhere you want, but write the name of the function or the equation that you graph. And this is all we knew from the very beginning. Okay, now I would like to look at some word problems because I want you to, we practiced these before, but let's look at more word problems that involve quadratic models. And here's one. So let's take a look at this experiment. Assuming that I have a ball in my hand, I don't, I have a marker. And I want to throw the marker and just follow the trajectory of the marker. Did you see what it did? It reached the maximum and then eventually hit the ground. What type of trajectory is that? What type of function is that? It's definitely not linear. But what is it? Quadratic. Quadratic. So we're given the following, let's say problem 60 on page 361. A ball is thrown upward and outward from a height of 6 feet. Okay, so we're given the height, f of x, height. And this is in feet. And they're giving us the model. And you will add, I'm going to ask you, and you will tell me what type of function. And x is the ball's horizontal distance. So, can anyone identify this function? What type is it? Anyone? Not Vinny? Quadratic, right? It has a coefficient times x squared plus another coefficient times x plus a coefficient. We've looked at this, we've seen this in solving quadratic equations, now in functions. Perfect. Okay, next question. What is the maximum height of the ball and how far from where it was thrown does this occur? So I'm standing here. I'm throwing the ball. It reached the maximum height about here, about this point, right? When x is, I'm not sure how much. And this is the height. So how far away from where I throw it up in the air? Maybe, I don't know, maybe 4.5, 5 feet. How high? I don't know, maybe 6 feet. Okay? So we need to determine both. In order to determine the height, what do I have to determine first? Can I determine the y-coordinate of a function before I determine the x-coordinate? No. So I have to find the x-coordinate. So, by the way, I should have asked you, does this function have a max or a min? Is it like this or like this? Right, because the leading coefficient is excellent. So now, how do I find that maximum? What do I need to determine? I need to determine, of course, I need to determine the vertex, of course. I need to determine negative b over 2a. b is 3.2. 2 times a is negative 1.6. So I'm standing here, I throw the ball up in the air, and 2 feet from where I'm standing, it reaches its maximum. 3.2 over 1.6 is 2. 2 feet. So 2 feet away from me, it reaches its maximum. But now I'm interested to determine the maximum height it reaches. How do I determine the maximum height? Say it again. Excellent, thank you very much. So this is indeed f of 2. I want to do this with a graphing calculator. You can, if you want to evaluate this function for other values, I recommend plugging it in. So in y equals, so clear on y equals, right here, y equals, and type in the function, negative 0.8 x squared. So the negative is the negative, not the operational, x squared, plus 3.2x plus 6. Let me know if you need help with this, please.
What is 0.8?
Oh, yes, thank you, thank you. Sometimes I click on, it doesn't take it. Maybe I didn't click this time. My apologies. Thank you so much for keeping an eye on me. Thank you. Okay, make sure that you have a second and table set. The software goes back to the default. I always have to do this every time I start a class. So now I'll go back to second and table. And in this case, I want to plug in 2. Now, if I plug in 0, what do I determine? If I plug in the function x equals 0, what do I always determine? The Y-intercept. Very good. So let's see what that is. They already told us. What should it be? Look at the function. Look at the 6, indeed. Very good. Perfect. Okay, so then we have 9.2. So this is 9.2. So 2 feet away from where I'm standing and throwing the ball up in the air, 2 feet away, it reaches its maximum. What is its maximum height? So that's part A, and we have to answer. Max height is 9.2 feet. Part B. How far does the ball travel horizontally before hitting the ground? So one more time. 2 is how far away from where I'm standing and throwing it. The ball reaches its maximum, how far away from where I'm standing. And this is the maximum height. Now in the next question, in part B, they're asking us how far does the ball travel horizontally before hitting the ground. So I'm standing here, I'm throwing the ball. Now I want to know how many feet away from me it hit the ground. What am I asked to determine? I can for now picture the graph. I have 2, 4, 6, 8, 10. So 2 feet, 9.2, and 6 feet. So I have this. Of course, this will be the axis of symmetry, and I don't care of what happens behind me. I don't care this way. Maybe I should do this. I'm sorry for you. Okay, sorry about that. So I'm throwing it up in the air. So I'm standing. I'm not standing 6 feet tall, but I'm here throwing it up in the air. 2 feet away from me, it reaches the maximum of 9.2, and then eventually hits the ground. We want to determine how far away from where I'm standing it hits the ground. What am I asked to determine this time? X-intercepts, indeed. This is what we are very subtly asked to determine. They're not telling it us point blank, but they're asking us to find the x-intercepts. So remember, the function was negative 0.8 x squared plus 3.2 x plus 6. How do I determine the x-intercepts? And there is also part C, graph the function, which we already did. So how do I determine the x-intercepts for this function? Perfect. So we set it equal to 0. Negative 0.8 x squared plus 3.2 x plus 6 equals 0. Excellent. You know me, I'm going to ask you, what do you think I am going to do? And I know you know what I am going to do. Right. And also multiply everything by 10. So I'm going to multiply by negative 10 and get 8 x squared plus 32x. Of course, I'm sorry. This is minus and minus. I already said minus. So the first one is positive 8, but the next one and the last one, negative 32 and negative 60. I'm taking care of the sun instead of, maybe I don't have to. If I don't stand in the way, maybe this is okay. Yeah, okay. I think it looks okay. So now, of course, I'm not going to attempt anything else but the quadratic formula, although I could simplify by 4. Yes, let's also divide by 4. So I have 2x squared, 8x, and 15 equals 0, to have as small numbers as possible. So then, the quadratic formula that we just wrote 10 minutes ago, negative b plus or minus b squared minus 4 times 2. But since this is negative, I'm changing the sign in front instead of putting nested parentheses, because be very careful. If you omit any of the parentheses, then the answer would be wrong. Any questions on this? Should I do this again? Anyone? Is this okay? So negative b plus or minus b squared minus 4ac minus 4 times a times negative 15, but I have a minus from the formula and minus 15, that the two will turn into positive. So now let's do this with the calculator. Please don't forget, I'm sorry, let me go back for a second. When you put this in the calculator, you must have most of the calculators, maybe not the new ones. In the graphing calculator, I am going to put parentheses. Even if some of them are redundant, you know me, I have to have parentheses. So parentheses around the quantity under the square root and parentheses outside for the numerator. Now the denominator is just one term, there is no need for that. So left parenthesis, uh, 8 plus the square root in parentheses. In some calculators, the parentheses already pop out. You can't even go around that. So 8 times 15. Close the parenthesis, go outside of the square root, close the parenthesis, and divide by 2a, which is 4. And now, repeat. And we know from the graph, we already graphed the function. We know it's going to be, we have a cheat sheet right here, right? So we know it's going to be a negative number, but that's okay. Let's determine the other one, which will not make any sense for us. So it's negative 1.39. So 5.39 feet away from me, it hits the ground. 2 feet away from me, it reaches its maximum. So x equals approximately 5.39 feet. And x equals approximately negative 1.39 feet, which is algebraically it's correct, but when it comes to our function and our situation here, it means nothing. So this is one type of example, and I'm hoping that once you start doing your homework, you're going to come up with more. Should we look at another example or continue? Continue or look at another? Another one, very good. Okay, 64 on 361. Among all pairs of numbers whose difference is 24, pairs of numbers whose distance, sorry, not distance, difference, sorry. Difference is 24. Find a pair whose product is as small as possible. Find a pair with the product as small as possible. So among all pairs of numbers whose difference is 24, find a pair whose product is as small as possible. So please give me an example with two unknown numbers. Do not pick any numbers. Two unknown numbers whose difference is 24. How will I write that? Is there a way of putting that in writing?